Welcome back, dear students. So we were doing chapter amplifiers of class 11, and we had already seen the basics of and the meaning of amplifier, why we need an amplifier to increase the power of a signal over the duration of time. So amplifier, the basic component used in amplifier, like I discussed in the previous class, is a transistor. Okay, so a transistor is the basic component of amplification. So सिर्फ एक transistor, if you just get a transistor from the market and you hold it and you say चलो amplify, it's not going to amplify. You need to bias it. Bias मतलब attaching batteries and cells. So there are various ways of biasing a transistor. Biasing मतलब giving it power. Okay, so this we had stopped here. The types of biasing. So what is basically biasing a transistor? That means biasing a transistor is the process of setting the operating voltage or current to a correct perfect level, so that koi bhi AC signal aaya, whatever AC input signal you're getting, that can be amplified correctly. It should not be that the AC signal which I'm going to get should be of a particular range. Only then amplification should be done. Though there are such ranges, optimum performance is attained when any AC input which is given to the amplifier, it should be able to amplify that particular any AC input signal. So that process, uska operating condition, last time I had told you what is an operating condition. On the DC load line, the middle point is the Q point. Okay, and this is the operating point. So when you find the X and Y components, it is IC, that is the sorry, the collector current, and the VCE. So whatever that this point is, X and Y coordinates, this is the wo jo coordinate hai, that should be aligned in such a position that you get this value of VCE and this value of IC. Okay, so that's the Q point, and that Q point is known as the operating point of a transistor. That is why ye wo value lane ke liye you have to set the transistor accordingly. You have to give the power, you have to give the external DC battery voltage accordingly. Okay, to get that. So the types of transistors, the first one which you're going to do is fixed bias. There are many types. As I said, there are many types, but the first one is fixed bias. We're going to do this collector to base bias. These two biasing techniques we are going to do in this lecture. Fixed bias with emitter resistor is not in your syllabus this year. This year it is deleted, but definitely next year, from next year it will be added on. And the last two, voltage divider and emitter bias, we are going to do in the next class. Fine. So let us start with the first one, that is fixed bias. Fixed bias circuit. If you can see this circuit towards my right hand side, this is known as a fixed bias circuit. Now, what does a fixed bias circuit do? Why is it known as a fixed bias circuit? It's known as a fixed bias. As you can see, there is a battery over here. You can name it VCC, you can use VVV, anything. Okay. This VCC, the battery which you can see, it is fixed over here. The value of this particular VCC is fixed, and hence it is known as a fixed bias. Okay, so VCC is a fixed value, and because it is a fixed value, when RB is selected, the base current IB is also fixed. Okay, so this is also fixed. RB a particular value hoga, for example 2K3, whatever the value is. So you know IB also, VCC is also fixed, RB is generally fixed, so IB is also fixed. Hence it is known as a fixed bias circuit. Basically आपको शुरुआत कहाँ से करना है? Because this one, VCC, the battery is fixed. Okay, therefore this is known as a fixed bias circuit. Fine. So in this, every circuit in your textbook also you see, every type of circuit आपको explain करने बोला जाएगा. आपको क्या करना है? You have to first draw the circuit diagram. Then you will explain why it is known like that. Third one, you will start with the derivation. Derivation is for class 11, as I suppose, is very, you cannot even call it a derivation. Only 2 to 3 steps mein you have to write what is the voltage or current equation you have to write. Okay. So in your textbook, actually, this is the way a fixed bias circuit is with capacitors and all. But in your textbook, these capacitors are missing. Okay. Why is it missing? Because when you are solving the circuit, the capacitors are considered to be open circuit. Because this we need not go into detail for class 11. Just remember that in DC steady state, ये charging component होता है capacitor, है ना? Capacitor is known as a charging component. वो full charge होने के बाद does not draw any current, so it acts as an open circuit. So आपके textbook में already इसको delete करके ही circuit बनाया गया है. Okay, so you can ignore the first step. The first step you can just ignore, but this step is valid. The step is valid for others. Okay. So first step is we look at the capacitors and replace them with open circuit. That means वो delete हो गया. Open circuit मतलब delete हो गया. ठीक है. Next, what are we going to do? We need equation. हमको चाहिए equation. Okay, we need equation of VCC or VBE. Before going to that, understand what is VCC and VBE. This is the collector terminal of the transistor. ये transistor है. ठीक है. This is the transistor. This is the collector terminal, this is the base terminal, and this is the emitter terminal. So the voltage between collector to emitter, this is VCE, voltage between collector to emitter. This is VCE. This voltage, this is the voltage between base terminal and emitter terminal. Hence, it is known as VBE. IB is the current through the base. IC is the current through the collector. Okay, so we need some equation which is going to connect all this, and for that we need to apply KVL in certain rules. Okay, in loops. तो देखिए पहला वाला ये इधर से current goes here also. Current goes here also. So there are two loops. This loop is 1 and this loop is 1. That is why it is written BE loop, CE loop. Base to emitter का एक loop है, collector to emitter दूसरा loop है. ठीक है? चलो. Let us start with the with equations. Fine. I will clear all my drawings first. Fine. And let us start. So for fixed bias, I will start here. Okay, so fixed bias, first and foremost, always remember that the source, this is the source voltage, right? VCC is the source. Source से जैसे जैसे current नीचे नीचे आएगा उसमें voltage drop होते जाएगा. ठीक है? So the main source voltage VCC, what will it be equal to? नीचे आ रहा है तो आपको क्या दिख रहा है यहाँ पे? IB RB, वहां पे voltage drop होगा. Voltage मतलब क्या होता है? Current into resistance. So can I write IB into RB? Yes, plus. Okay. As you come down, यहाँ पे एक voltage drop दिख रहा है आपको VBE, यहाँ पे दिख रहा है, और फिर ground. Ground मतलब खत्म. It's finished. So in this loop, in this section, left hand side, what will you get? VCC is equal to IB RB, and then you get VBE. Sorry. VBE. Okay, right? Now, so I will repeat once again. VCC being the source, VCC being the source, I will write VCC equal to, in this left hand side, this is being the source. So as the current is going down, there is going to be voltage drop across this resistor. Voltage is current into resistance. IB is equal to IR by Ohm's law. So I will write IB into RB plus, as I go down, I see one more voltage drop across these two terminals, that is VBE. Okay, so now I can write IB is equal to, okay, I will bring IB to one side, all the other terms I'm going to bring it to the other side. So it is going to be VCC minus VBE. Okay, VBE divided by RB. Okay, so I'm going to put a bracket over here and then I'm going to write divided by RB. I hope this is clear. I have just separated IB. Fine. Now, VBE is very negligible. Okay, so VBE is very small. So that is why we can ignore VBE. So we can write IB is equal to VCC divided by RB. Okay, so this is going to be a final equation. Similarly, for the right hand side of the loop, we can write VCC is equal to, as I said, आपको दिख रहा है RB और RC दोनों parallelly connected है, right? So you can see RC over here. So there's a voltage drop going to be over there. So that is going to be RC into ICRC. I'll write ICRC. That will be better. ICRC plus, you can see a voltage drop right here. So that is going to be VCE. Okay, so if I want to, why am I choosing IB and IB is equal to, पहले इसमें मैंने IB निकाला था, second इसमें मैं VCE निकालूंगी, because this is operating point, है ना? Operating point के लिए हमको कौन से coordinates चाहिए? VCE and IB, इसीलिए मैं वो निकाल रही हूँ, ठीक है? So इसके हिसाब से VCE becomes VCC minus ICRC. Okay, so please understand why I did it. I did it because IB and VCE ये दो चीजें हैं operating point. ये मुझे set करना है उसके हिसाब से. That is why मैंने IB और IC को निकाल दिया. ठीक है? I think things are clear. And this is known as a fixed bias. VCC is fixed and you get two resistances connected to the source, RB and RC together. Fine. Now, let us see what is the advantages of this particular fixed bias circuit. So this particular circuit, fixed bias circuit, has certain merits and demerits. We'll see that. And the merits are, as you can see over here, minimum amount of components are required. As you can see, only two resistances are required, right? So the number of components, very few components are required. That is only two resistors, RB and RC, and a battery is required. And one more important merit is that you can easily fix the operating point anywhere in the active region. IB and हमने VC और IB को बहुत आसानी से निकाल दिया, है ना? But there are certain demerits also. This IC जो है ना, this does not remain constant. Temperature variable hai ye. As the temperature increases, IC may also increase. Okay, that is why the operating point can also change. So that is one of the you can say demerit of this particular circuit. Okay, so these were the merits and demerits. You can take a screenshot quickly. Now, so whatever I have said, I have just summed it up in this slide. You can quickly take a screenshot. Now coming to the next type is collector to base bias circuit. Okay, so this is the collector to base bias circuit. इसमें क्या अलग किया है इन्होंने पहले जैसे? देखो पहले का दिखाती हूँ मैं. See, here you have the battery VCC and there are two resistors connected across, right? Two resistors. Now look at this. इसमें देखो क्या अलग किया इन्होंने. यहाँ पे RB था, है ना? पहले इसमें the RB was connected right here, but now what they have done, they have taken it off and they have connected it to the base like this, right? That is why it is known as the collector to base bias circuit. Now in this type, the base, as you can see, RB, like I said, is connected to the collector instead of connecting it to the VCC. Is it connected to VCC? No, it's connected over here, right? That means to the collector of the transistor. Okay, collector and base ke beech mein wo connected hai. Fine, that is why it is known as collector to base circuit. Again, in this same thing, again you have to do, we have to first draw the circuit, understand the labeling, battery VCC, collector resistance is RC, base resistance is RB, base to emitter VBE, Collector to emitter, voltage is VC. Okay. Now what we have to do is find out what is VCE and IB, because operating point find out karna hai, right? Now, as I said before, same thing is applicable over here. We will now trace the, oh, sorry, just give me a minute. We will now trace it like this, trace the current as it is going through VC from VCC, it is coming through RC, and then it has made a voltage drop across VCE. So we are going to write that first. So I can write VCC equal to ICRC, because उसके across एक voltage drop होने वाला है, plus VCE. Okay, so ये इक्वेशन के हिसाब से VCE क्या होगा? VCE इक्वल टू क्या होगा? VCC प्लस ICRC. ओके, oh so not plus, I'm extremely sorry, ये दूसरी तरफ जाएगा तो it will become minus, है ना? क्या किया मैंने? Please understand what I did. What did I do? VCC is equal to ICRC. I just traced this much part. ठीक है, मैंने ट्रेस किया VCC से करंट कहाँ कहाँ जाएगा, दिस प्लस दिस. ठीक है, तो मैंने वो सिर्फ ट्रेस किया. आई डिड नॉट डू एनीथिंग न्यू. व्हाट आई डिड, आई वांट ओनली VCE, तो मैंने इसको इधर ट्रांसफर कर दिया, राइट? तो ये इधर जाएगा तो उसका साइन क्या होगा? इट विल बी नेगेटिव. ओके, आई होप आई हैव मेड माय सेल्फ क्लियर, एंड हेंस आई गॉट द फॉर्मूला ऑफ VCE. Now what I want IB. Now for IB, what I'm going to do is we will track the next part. Okay. Now, one important thing that you need to know over here is the current which is flowing through this. Okay, the current flowing through this. One important thing is the current flowing through this, I have considered it as IC, right? But it is actually IC plus IB. Okay. Why did I do this? Because ये IB के लिए भी करंट भेजने वाला है यहाँ से. It is going to be IB. यहाँ पे ब्रेक हो रहा है ना? Can you see? This is the breaking point. यहाँ से ये IB बन जाता है, यहाँ पे वो आगे जाके IC बन जाता है. तो ये ऊपर वाला क्या हुआ? उसका टोटल हुआ, right? This part is IB, this part is IC. तो ऊपर वाला उसका टोटल हुआ IC plus IB. तो आप पूछोगे मैम यहाँ पे तो आपने RC के अक्रॉस सिर्फ IC लिया. क्यों लिया? क्योंकि here IB's value is very 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 less than IC. So I have ignored that. Okay, क्यों ignore किया? क्योंकि मुझे I was just concerned to take IC into picture. That is why. Fine. So that is why, that's the reason I did not tell this before. So because through IC it is easy to understand, इसलिए मैंने वो पहले बोल दिया. But अभी in case में I want IB, that is why I will have to introduce IB, है ना? IB introduce करने के लिए I am using this as IC plus IB, and it divides into two parts, IB and IC. Fine, clear? I think I've made myself clear. Now, now what is, we will start tracing. Okay, main battery voltage VCC equal to RC के across अभी क्या होगा? voltage drop होगा, है ना? But that will not be IC only. What will that be? IC plus IB into RC, है ना? Voltage into current is voltage drop, है ना? इसीलिए. Fine. Plus, as I'm going this way now. Okay, I'm going this way right now. I'm going here. What will I see? यहाँ पे मुझे IB RB दिखेगा. So that is plus IB into RB. Fine. After solving, let us solve this. VCC equal to ICRC plus IB RB RC. Sorry. What am I doing? मैं सिर्फ RC को अंदर ब्रैकेट के अंदर मल्टीप्लाई कर रही हूँ, ठीक है? Plus IB RB. Fine. Now I will take ICRC to the other side, so this will become VCC minus ICRC equal to IB RC plus IB into RB. ओके, VCC माइनस ICRC पहले वाले इक्वेशन के हिसाब से क्या होगा? ये वाले इक्वेशन के हिसाब से VCC माइनस ICRC ये क्या होगा? देखो यहाँ पे it is going to be VCE, वही है ना, VCC minus ICRC वही है. So can I substitute? Definitely I can substitute. So this becomes VCE. बाकी सब सेम रहेगा, equal to IB. Can I take IB common? Definitely I can take IB common. IB into RC plus RB. Okay, now in this case, there is one more important thing to be noted down, that over here, it is not just RC which we are considering beta RC. Actually, beta is this beta, okay? It is like this. But I am in this particular keypad, it's not giving me that. It gives this beta only in the word and all. So that is why I'm unable to write, but it is this type of beta. Okay, beta factor, current amplification factor. Okay, so this is the final required equation. But हमको VCE मिल गया, हमको और क्या चाहिए? IB चाहिए. तो हम IB को इस तरफ एक तरफ रखेंगे, बाकी सबको दूसरी तरफ रखेंगे. IB is equal to VCE divided by beta RC plus RB. Okay, fine. So this is the final equation for IB and VC. दोनों operating point, दोनों coordinates operating point के हमें मिल गए हैं. Okay, so this is the second type of bias circuit, how you can bias a transistor, collector to base, and the first one was fixed bias. I hope I've made it clear. Any doubts, please feel free to ask, and stay safe, stay happy, happy learning. Thank you.